That lesson is much more involved. Took me 2 or 3 days with my kids. The first part is just about friction and motion, where you're going to have 3 boards that Tom has already said after you create these you can keep in your school. You don't have to send these back, so you don't have to create them next year. You have a hot glue gun which you could work, or what I had just done very quickly is just use some masking tape to attach the sandpaper. When you were going through the kits, you probably saw 2 different types of sandpaper. Fine sandpaper and coarse sandpaper, which is a lot heavier. And something else for you to talk to your kids about is how to build it. Because obviously if one group builds it like this, one group builds it like this, that's a whole nother issue as far as control variables, as far as how much is covered, how much isn't. And the masking tape does kind of help as far as easing the bump between the transition. So the first part of it is just a qualitative observation. First, they just observe the 3 surfaces. The regular cardboard, the half and half with this, and the half and half with this. And then they just take the sand tub, which again, very helpful if it's taped, so when it tips over and hits the ground, you don't get a big mess in your classroom. So they're just going to very briefly, slowly pick this up until it slides down and observe what happens. Then they're going to do the same thing with the half cardboard and half fine sandpaper. Pick it up slowly, watch what happens. And they can also try it the other way as well, as far as picking it up. Okay, it's going to take a while, but then once it gets here, they should see it speeds up after that. And similar with the heavy sandpaper as well. That part of the lab is on page 51. Page 52 on the reverse side of that is using the same materials, but now you're talking about the force, is where the spring scales are going to come in. You have the one that measures a heavier force and the one that's very fine-tuned, only goes up to 2.5 newtons. So you can use different things to try to attach this. Some kids were trying to tape this on. Jonathan has a way as far as using the tape measure and hooking it on.
Or just a piece of string. You tie a loop around the string. This is a quick tie. If you have your string and you just put the 2 ends together of your string, not the tape measure, and then you just loop around the string and then pull it through the loop and then pull it tight, it's a quick tie. Kids can do that. And it's not gonna, the higher you tie it, the tighter it becomes. So this is just a quick tie knot.
So what they're going to measure here, if they hook this around the sand tub, they're going to measure the force that it takes for them to get constant motion across this surface. So they're going to want to work in partners here with one person pulling, the other person trying to read the spring scale. And they're not looking for, okay, what's that? But they're looking, okay, what force is needed for constant, steady motion? And for the regular cardboard, that's where you're going to want the fine-tuned one, because it's a very light force needed that won't really register on the heavy one. That's why there are 2 different spring scales. So they'll do it on that, they'll do it on the fine sandpaper, and then they'll do it on the heavy sandpaper as well. And obviously they'll see that it should take more force because of the friction involved with the sandpaper. That here's the lesson where you're really going to be talking about friction and introducing that concept to them. And then on page 53 is an opportunity for them to design their own investigation. Okay, here's your testable question. How are you going to do this now? How are you going to investigate how does mass affect the force of friction? That you then did this on 52, how does the amount of friction affect the force? Now on 53, you're asking, how does mass affect the force of friction? That you could use a sand tub that's half full and a sand tub that's completely full. 2 different masses. Does this affect the friction? And they can work out their own procedure to test this out, record their 3 trials, calculate the mean, talk about multiple trials, and then there's another opportunity on the back of that on 54 for them to graph that and write a conclusion as to what they found. All kinds of opportunities for integration there and inquiry. Any questions on that lesson that I know?
The first day they do the incline and then the pulling with the newtons, and then the second day they do their inquiry? It'll
depend on how much time they have, how long it takes. It took me 3 days to get it all done because my kids had never used a spring scale before, so I had to spend a good 15 to 20 minutes talking to them about, okay, how does a spring scale work? What is a spring scale? What's the difference between the side labeled G and the side labeled N? How does it work? What do we use it for? How do we read the scale on there? that, you know, for instance, on the lighter one, where it's, you know, the big labels are 0, 0.5, 1, 1.5, you have to talk about, you know, number lines with tenths and hundredths. That takes up more time as well.